Now, here we consider the correlation coefficient between the next type of problems we are going to solve. Here we consider the correlation coefficient between asset I and j as always is equal. That means rho ij, which is the correlation coefficient existing, is always fixed. So, if we expand the covariances, so covariances are basically three terms. One is the correlation coefficient, one is the standard deviation on the I, one is the standard deviation of j. So, when you are considering these three terms, you will consider one as fixed. So, generally when you have the variance covariance matrix, what you have is basically the principal diagonal is the variance of the first, second, third, fourth till the nth one, depending on if there are n different matrix, and the of the diagonal element which you have are basically the covariance variance values, covariance values of the ith to the jth or the first to the second, so on and so forth. So, if you have in the first row and the second column the covariance of the first to the second, in the second row and the first column you will basically the covariance of the second to the first, but considering the symmetricity obviously these values would be equal. Now, what you are simplifying is that you need to find out only the returns which is Ri bar, the standard deviation which is sigma I or sigma j, and the correlation coefficient you need not be bothered because you will only consider a fixed value. So, now your ranking would be done in the case where till now you are considering the excess return to the beta. The beta means the beta which is a proxy of the risk for that particular stock with the market. So, now you will basically consider the excess of that particular stock with respect to this its own standard deviation. Again the simple formula, when there is no short selling, you will include those particular stocks in the portfolio if excess return to standard deviation, not beta, standard deviation is greater than some C star, again I am using the symbol as C star, and if the excess return to sigma is less than C star, obviously you will not include it when there is no short selling. When you come to the short selling case, again the same rule, excess of return divided by standard deviation, if it is greater than C star, you include in a positive sense, excess of return divided by sigma, if it is less than C star you include, but in the short selling sense. But again in the short selling sense there will be two arms, non-Lintner's definition where the sum of the weights is equal to 1, and Lintner's definition where the sum of the mods of the weights is equal to 1. So, again you will follow the same policy in trying to differentiate the three cases, short selling allowed, short selling not allowed, and short selling allowed using the Lintner's definition. When I use the word short selling allowed, it means I am using the non-Lintner's definition. So, problem has the condition short selling not allowed, riskless lending and borrowing being allowed. So, the rule works as follows, excess return greater than C star where the denominator is sigma include, excess return less than C star do not include. Again I am taking a different example with 12 stocks. The first column is the stock number, second one is the return, third one is the excess return only, not divided by any standard deviation, third one is the standard deviation, fourth one is basically the excess return to standard deviation. So, what I have done in this slide is basically in the other one I have broken down into two different slides and basically done the calculation. So, I am trying to basically compact that and try to give you the results. Only remember the formula which we are using is different. I am not interested in trying to discuss the proof of these formulas that can be found in Elton and Group or any good book like Investment Sciences by Leuenberger, which I have already discussed. So, I will just go through the simple calculations without going to the depth of the proofs and the theorems. So, again in the fifth column you basically have the excess returns to standard deviation, then you find out the formulas. So, once you find out CIs, again you find for the case when there is no short selling there is one particular value of C star which is the maximum value, after which again CI value starts to basically decrease. So, if you come to these values, remember another thing, whenever again a repetition, when you are trying to find out the summation, it is basically j is equal to 1 to n or j is equal to 1 to I, and I basically means that a particular asset till which you are trying to find out the value of CI. C star is given by this formula where rho is basically the constant correlation coefficient which you have already considered, and these weights are given by these formulas. The C star is different for different, this C star value which you are trying to find out is different from the C star which you have considered originally, where your actual formula was this, where you are trying to rank it according to beta I. So, this C star which you are considering and this C star which you are considering for the case when it is Ri minus Rf by sigma, these two are different. Remember that. So, the values of CIE find out 4, 5, so on and so forth, 5.25, which is the third value in the last column which you just saw in the overall calculations. Using the formula, if you find out the non-normalized weights, they come out to be 44 by 24, 42 by 24, 9 by 24. So, you add up, it doesn't come out to be 1, you normalize them using the concept normalization as we have been doing. If you see, the weights come out to be almost equal to 1. So, that means you will invest 46% in the first, 44 in the second and about 9% in the third, and the rest would not be included because their excess return divided by sigma is negative with respect to the C star value which you found out, and obviously the case that short selling is not there. Extend the problem through the case where you have short selling allowed, Lintner's definition not being allowed. Again the same concept, riskless lending borrowing there, short selling being allowed. Again with repetition, Ri minus Rf divided by sigma is greater than C star, include Ri minus Rf divided by sigma less than C star, include, but in a negative sense. Again the same formula, first column is the stock number, second is the returns, third is the excess return, fourth is the standard deviation, fifth is the actual ranking which you are doing by dividing the ratio of the excess return divided by the standard deviation. So, again we use the same formulas, but with a caveat and an important note that the n which you are trying to find out in this problem is for the whole set of assets which are in front of you. So, n would be basically 12 for your case, but for the just example which is we solved concerning short selling was not there, we will consider that n would be that particular asset till which we are trying to find out the CI values. So, the values come out to be of CI comes to be constant which is 3.65. So, we will include those assets in positive sense where it is greater than the 3 point value which you have found out for C star, so called C star, and in a negative sense for other stocks. Remember another thing, the summation is always for n which is 12. So, here is the formula for C star and here is the formula for Wi. Once you use this, your non-normalized weights come out to be this, which technically means that if you add up, obviously there is not one, but if you do the concept of normalization using the Lintner's and non-Lintner's definition, obviously we will get two different answers. In the non-Lintner definition, this is true, Lintner's definition, this is true. So, whichever you use, be sure that depending on the formula which you are trying to use, your normalization would be done according to that. Because if you are doing the normalization case for this one, so obviously you are following the Lintner's definition. So, in this case you are trying to basically compensate some collateral such that if there is any risk or non-payment or non-returning of the stocks from your part to the person from whom you have borrowed, then he or she basically has a collateral in order to overcome the overall risk. Lintner's definition you consider, again the same thing, greater, less, you have to include in the positive sense, negative sense. But only again remember the division which you are doing for ranking is sigmas, not betas. Again use the same formulas, but find out the value is again 3.65. Sums are always from j is equal to 1 to 12, which where n is 12. The formula for C star remains the same, formulas for Wi's remain the same. When you do it, you find out the normalized weights again comes out to be as per the formula what you are using, the normalized weights come out to be the Lintner's definition. Check that summation should be 1. But this summation which I am using for the Lintner's case, this is the summation. For the non-Lintner's case, this is the summation. So, this is very important to be noted in both the cases. Now, the capital asset pricing which we have already dealt with that, but we will now go into the details for that. So, what we are going to consider is that given a particular stock, how can you find out its overall change in the price or find out the returns given that the market is changing. So, if you remember in the few class back we considered the single index model. So, in the single index model the problem was exactly the same. We are not going to go into the details of that, we will skip the slides if they are there, but only go into the actual concept of how the CAPM model is being utilized. So, when you are considering the single index model, we considered there was one dependent variable which is Ri, or which is say for example y, and on the right hand side if of the equation there is basically alpha, which is where the line straight line cuts the y axis, and there is basically beta I into Rm bar. Basically bar we are considering as the average value. So, beta is basically the tan of that angle, which is basically a slope, and if you are not taking the average values, obviously there would be a white noise which is epsilon. So, if you take the expected value, then on the left hand side you have Ri bar is equal to alpha I, because this is a constant, theoretically we are considering as a constant, plus beta I into Rm bar plus epsilon is not there. So, obviously it would not be there, and based on that you find out the best line and try to basically find out how the prices are changing. If it is a multi index model, obviously in case of only one index, now we will basically have more than one index. So, those indices would be given by say for example I1, I2, I3, I4 whatever is there, and you want to basically find out the relationship of the rate of the change of the prices of the particular stock with respect to each and every i's. So, obviously in the multi index model you have a relationship where the price of a particular stock would be dependent on different type of independent variables. But the CAPM model considers is basically a way how you try to analyze the problem from the single index model. So, having said that, and I am sure the students who have already gone through the single index model would be in a much better position to appreciate how CAPM models are being utilized, not from the sense of theoretical knowledge how you derive it, but from the sense that how it can be utilized in the market sense in order to understand how the particular stock is doing with respect to the market, and how changes in the market would basically give us some information in the change of the particular stock, and how good or bad that particular stock is with respect to the market, whether one should invest or not invest. So, in the capital asset pricing model, we are mainly concerned with two important problems. What is to determine the best course of action in investment processes, and that is how to devise the portfolio and how to make a decision whether you include or not include that particular stock, and to determine in a very correct sense the arbitrage free or fair equilibrium price based on which you can decide whether the particular stock should be included or not included, and find out the rate of return for that particular stock. So, in answering the second question, we will come across the CAPM, which was developed by Sharp, Lintner and Gosen. So, basically I will just discuss the general trend of the general concept of CAPM, and basically go into the other concepts which would definitely give us a good picture of how the prices can be found out for the portfolio point of view. So, now if you remember in the single index model, I only dealt with the assumptions which are there from the theoretical point of view, from a statistical point of view. One was expected value of the error is 0, covariance between the errors from time 1 to time 2, time 2 to time 3, so on and so forth is 0, covariance existing between Rm and the white noise is 0, and we consider also normality to be true for the returns of the market as well as the return of the stocks. So, those are all from the statistical point of view. Now, the question would come that, well, that was fine from when you are solving the single index model from the theoretical point of view. What if we try to utilize that exact model in the CAPM one? So, now obviously there would be some assumptions. So, the assumptions are, we will consider there is no transaction cost. And if you remember, I did mention in one of the classes when we were trying to do the portfolio one, when we were discussing the Markovich model, we did discuss that there would not be any transaction costs, there would not be any dividends, there would not be any brokerage costs, so on and so forth. So, those were on the very simplistic sense. So, obviously, we will see later on that using formulas, using some solved examples, how they can be relaxed in order to get much more practical and much more solutions which are totally removed from theoretical sense and more akin and more closer to the actual market. We will consider assets are infinitely divisible. That means you can buy and sell assets in one unit only, but there may be cases where the assets you cannot buy in quantities of one. You may be required to buy and sell hundreds of such assets at one go. So, we will relax that assumption. We will assume that there is no personal tax. So, the reason being that if this personal tax, obviously the buying and selling, like the case when you have the brokerage price, that will affect our overall solution. We would not consider that to be present in our problem. We will also consider investments buying and selling does not affect the equilibrium price. So, if you consider in the demand and supply case, there was basically a price and the quantity. So, this price would not change dramatically as the demand and supply curve changes. So, it will basically be instantaneous in the sense any movement in the demand and supply would be immediately reflect in the prices and the quantity of the particular stocks, such that the prices which you have in front of you reflects the market to the maximum possible extent without any asymmetricity in the market. We will also consider investor make decision based on the risk return profile only. So, if you go back to our initial problem where we considered the utility function, where it was a person invest depending on non-cessation and the person invests depending on the case that he or she wants to reduce the risk to the maximum possible extent. We will consider investors invest only for the case where they want to maximize the expected value of the utility, and this utility is always on increasing trend, and they want to basically invest in particular stocks or set of stocks to form the portfolio where the risk is minimum. Now, if you also recollect, I did mention time and again, and I will definitely mention it time and again later on, that the utility function was quadratic. So, if it is quadratic, the square terms means that whenever I invest more amount of money W, obviously my utility would be on an increasing trend. That means I will get much more net worth for my investment. So, this would always hold true. And also I will consider that I will always take a decision where at the end of the day, if I have two different decisions where both the returns are same, but in one case if the risk is low, obviously I will take the one for the risk is low. So, with these two assumptions, which is basically the property of non-cessation and the property of taking being the risk averse, would also hold true for the CAPM model, apart from the first to fourth, which are very simple concept on the practical sense. So, if you consider these assumptions, the 5-1 and also the statistical one, then it makes sense in order to basically implement and combine the statistical assumptions along with the economic assumptions, and then try to basically formulate a one-to-one simile between the single index model and the CAPM model, so that once you understand the theoretical concept of single index model or the simple linear regression, which we call in statistical sense, then obviously it will make sense that how you can utilize the same concept in the CAPM model.